Yes, welcome to electrical machine lecture. Continue with the previous topic, that is armature torque. Already we have discussed 2 or 3 example. Now this next example is that a cutting tool exerts a tangential force of 400 Newton on the steel bar of diameter 10 centimeter, which is being turned in simple lathe. The lathe is driven by a chain at 840 rpm from a 220-volt DC motor which runs at 1800 rpm. Calculate the current taken by the motor if its efficiency is 80%. What is the size of motor pulley if the lathe pulley has a diameter of 24 centimeter? So the example says that a cutting tool exerts a tangential force, means the tangential force over the circular part. Suppose this is the circular part. This is the circular part. This is the circular part whose exerts a tangential force. So the force which is a tangential this force F is equal to 400 Newton on the steel bar of diameter 10 centimeter. This bar, it is turned into the simple lathe. So it is connected to the lathe machine. This is the lathe machine which is connected over there. And now whose diameter is 10 centimeter. So you can write as the radius is 5 centimeter. It turns into the lathe, means it is connected to the lathe machine. The lathe is driven by a chain at 400 rpm. Now it is driven by, means there is a shaft and there is some driving mechanism, wheel gears are there, and it is running 840 rpm from a motor 220-volt DC motor which runs at 800 rpm. The motor is running at 800 rpm. It means that the diameter of pulley which is connected over the motor is definitely less than the diameter of pulley which is connected on the lathe machine. So suppose this is the, now we would try to say, find either it is our assumption is correct or wrong. It is connected with the chain, and with this chain, definitely and it is running at 840 rpm, means the speed of lathe, now it become 840 rpm, whereas the motor which is connected over here, it is running at the speed of 1800 rpm. 1800 rpm. Whatever the size of the motor, calculate the current taken by the motor if efficiency is 80%. What is the size of motor pulley? We want to know what is the size of pulley. Either it may be a diameter or it may be the, say, diameter. Let the diameter of this one is D1 and the diameter over this one is D2, means which is connected to the wheel, which is connected over here. It may be some wheel is there, and now whose diameter is, this diameter is, suppose it is d2. Okay. Now definitely the speed is more, and here the speed will be small. So 840 rpm. It is connected with this one. Now we'll try to solve this numerical. First, we will try to calculate the shaft torque or torque. So shaft torque, or you can write the torque which is available on the this pulley, this over this one. TSH is equal to force into distance, radius of this one, R. So it is a 5 centimeter. So 400 multiplied by 0.05. So it is equal to, because we are converting meter into this one, so you just write over this one, R is the 10 centimeter. Therefore, it is equal to 10 into 10 is to minus 2 meter. So it is equal to 20 Newton meter. So it is, this one is 20 centimeter. Therefore, power output, which is equal to P equals to omega into T, means angular velocity multiplied by torque. So here it is twice pi n upon 60, because n is given in Newton, it is in RPM, into TSH, where n in RPM. It is equal to twice pi into, it is running at 840 RPM. 840 divided by 60 into 20. So now it is equal to, output of motor is 1760 watt. So this is the output. Now here it is given that the efficiency is 90%. Therefore, as efficiency is equal to, how much it is? 80%. 80%. Therefore, input is equal to 1760 divided by 0.8, and the power input is 2200 watt. This is the input. Now, once the input is available, we can calculate the current drawn by motor. Current drawn by motor, which is equal to input, power input 220 volt, 2200 watt, divided by the supply voltage 220, and the current drawn by motor is 10 ampere. So this is the some parameters. First is the power output. This is the output of motor. This is the input, and here is the current. Now what is remaining? We want to know what is the diameter of motor pulley. Okay, so let N1 and D1, speed N1 and diameter D1 be the speed and diameter, speed and diameter diameter of driver pulley Similarly, N2 and D2, N2 and D2, that is speed and diameter of will be the speed and diameter of lathe pulley. So we can write as N1 into D1 is equal to N2 into D2. Okay, so N1 is, we know, diameter of motor we are going to find out. So it is N2 upon N1. So 840 divided by 1800 into diameter of is given by 24 centimeter. So converting 24 centimeter into the meter, it is 0.24. Okay, we will write here where D2 is equal to 24 centimeter as it is given. So now the diameter of driver pulley, that is a motor pulley, D1 is equal to 11.2 centimeter. Means it is in 0.11 meter and this is centimeter. So this is our required answer. Now see, as we have assumed in the example, definitely when it complete 1800 RPM, so it will complete, means the lathe pulley is going to complete less than the 1800 RPM in the same time. So our assumption is correct. D1 is smaller and D2 is so it's somewhat wrong because the driver pulley is going to complete 840. So it means that the motor diameter will be how much? It is here, it is given that it is, and D2 is 24. We have considered the D2 is the 24 one. So definitely here the D1 is small. So our assumption is correct. Now we will see the next example. See the next example. Okay. So the next example is the armature winding of 200 volt 4-pole DC series motor is lap connected. There are 280 slots and each slot has 4 conductors. The current is 45 ampere and the flux per pole is 18 milliweber. The field and armature resistances are 0.3 ohm and 0.5 ohm respectively. The iron and frictional losses are 800 watt. The pulley diameter is 0.41 meter. Find the force on the pulley ring. Means we are going to find out. Suppose this is the pulley ring. This is the pulley. Okay. And we are going to find out the force on the pulley. Means we are going to find out what is the force over the pulley and its diameter. So its diameter. So what is the diameter of the pulley? You want to know this diameter is equal to how much? Okay. So what is given? Voltage is 200 volt supply voltage. DC series motor. 4 pole. P is equal to 4 is lap connected. It is a lap connected. It means that A is equal to P. Number of parallel path is equal to number of pole for the lap winding. The current is 14 ampere and the flux per pole is 18 milliweber. So current drawn by motor, it may be armature current is equal to series current. It is equal to the load current since it is a series motor. So it is 45 ampere. 45 ampere. And the flux per pole is pi is equal to 18 milliweber, means 0.018 Weber. And armature resistance and series field resistance. The field, armature resistance and series field resistance. So it is 0.3. And armature resistance RA is equal to 0.5. This is the resistance of armature. The iron and frictional losses is 800 watt. Now we will start the example. First, we will going to calculate the back EMF. So if you are able to calculate the uh, back EMF, then it is possible to calculate the other parameters. Okay. So like speed and all these things. So the back EMF EB is equal to back EMF. Just a minute. Back EMF EB is equal to V minus IA RA IA RA plus RSE, because it is a series motor. It is a series motor. Voltage is 200 volt. current is 40 ampere. Okay, and this is the motor, and here it will give the back EMF, EB. Definitely EB should be smaller than the supply voltage. So 200 minus 40, 45, multiplied by the addition of these two is 0.5 and 0.3, it is 0.8, and it is equal to, back EMF is equal to 164 volt. So see, the back EMF is smaller than the supply voltage. Now, once we know the back EMF, what is the back EMF? We can have the second formula. It is phi Z N P upon 60A, where Z is equal to, where A is equal to 4. It's number of pole and number of this one. Z is equal to the total number of conductor multiplied by the, there are 280 slots. So it is how many slots? 280 slots. And each slots carries 4 conductor. So this is the total number of conductor. So if you put this value, we get here it is 164 is the back EMF. Pi is the 18 milliweber. So it is 10 raised to minus 3 into the number of conductor 280 multiplied by 4. The total number of conductor upon 60 into speed, sorry, and speed multiplied by P by A. So it is 4 upon 4. Okay. So we get speed N is equal to 488 RP. So this is the first parameter. Now we are going to find out the total input. Total input. So total input is equal to voltage, power supply, V into I, and the current is equal to 45 ampere. So the power input is 9000 watt. This is the power input. Now, what is the copper loss? Cu loss is going to occur in armature as well as series field winding. So Ia square Ra plus Ia square Rse, since the current is same. So total we can write as Ia square Ra plus Rse, which is equal to 45 square into 0.8. So total copper losses equals to 1620 watt. This is the motor copper loss. Now total losses. Total losses is equal to Cu loss plus iron plus rotational loss or frictional and windage loss. So which is equal to 1620 plus these two losses are already given. It is 800 watt. So total comes 2420 watt. These are the total losses. Now total input we know, total losses we know. So you can calculate, we can calculate the motor output. We can calculate motor output is equal to motor input minus total motor loss. It is a loss of power. So motor input, it is 9000 watt minus 2420 watt. So the motor input PIN equals to 6580 watt. So this is the motor input. Now, sorry, motor output. So this is P out. It is motor output, say P out. So what is the shaft power? The shaft power of torque, shaft torque, TSH is equal to 9.55 into power output of motor in watt divided by speed in RPM. So 9.55 into 6580 divided by speed. Speed is given. Yes, speed already calculated 488 RPM. So 488 RPM. So shaft torque TSH equals to 128 Newton meter. So this is the shaft power. Now we want to calculate the tangential force and the diameter. So force is equal to, so torque is equal to force into, it is force into radius or radial distance. So where diameter of pulley is 0.41 meter. So half of this one will be, so therefore it is force we want to calculate, and radius is equal to 0.205 meter, and it is equal to 128 Newton meter. As D it is given 0.41 meter. So R will be 0.205 meter. It is given. Okay. So therefore force, so force on pulley, force on pulley F, it is equal to 634 Newton. So this is the answer for the given data. Now next example. A 4-pole 240 watt wave connected shunt motor gives 1119 kilowatt when running at 1000 RPM and drawing armature current 50 ampere and the field current is 1 ampere. It has 540 conductor and the resistance 0.1 ohm, means it is the armature resistance. Assuming 1 volt drop per brush, find total torque, useful flux, rotational losses, and efficiency. So what is type of motor? It is a DC shunt motor. Now we will draw the diagram of DC shunt motor. So this is, say, this DC shunt motor. It is better to draw the diagram. Back EMF. Now, what's the points is given? The armature resistance RA is equal to 0.1 ohm, whereas the voltage drop is given, and field current is equal to the 1 ampere. So this is the load current IL. It is armature current IA is the armature current, and the voltage of the motor is 240 watt, 240 volt. So it is the supply voltage. So what are the points are given? Datas are given. Voltage is equal to 240 volt. Now it it is a shunt motor, DC shunt motor. It is a wave connected, and the motor output it gives, means the output of the motor is 1119 watt. It is the motor output, and running at speed of the motor is 1000 RPM. The motor is running at this, and drawing the field current and drawing the field current, armature and field current. So armature current IA is equal to 50 ampere, whereas the shunt field current equals to 1 ampere. It has 500 and total number of conductor 540 total number of conductor, and resistance, armature resistance RA, it is 0.1 ohm, and brush drops are there. So now first we will calculate the back EMF. Back EMF. EB is equal to V minus IARA minus brush drop. Since the brush drop is given, if it is not given, we consider as it is equal to 0. So 240 minus 50 into 0.1 minus 2. So back EMF value is 233 volt. So this is the back EMF. Now once the back EMF we know, we can calculate the total torque. Means it is asked, first point is just the total torque. Say point A is total torque. Total torque, or you can consider as it is the gross torque developed by armature. Developed by armature. So it is TA, armature torque. It is equal to 9.55 into back EMF into armature current divided by speed. It is in RPM. So it is 9.55 into back EMF. It is 233 multiplied by 50 divided by, it is running at 1000 RPM. So armature torque TA, it is equal to 111 Newton meter. So this is the first parameter. Now, second. What is second? Second is useful torque. B part, useful torque. Useful torque means the torque available at shaft. That is the shaft torque. TSH, useful torque. It is 9.55 into power output of the motor divided by speed. So as the power output of motor is given, it is equal to 11,190 watt divided by 1000 RPM. The motor speed is same. So it is equal to 106.9 Newton meter. See here, the armature torque is greater than the torque of the shaft. So here the shaft torque is it is the TSH. This is TSH. So shaft torque is smaller. Or we can say that if you take the difference of these two is nothing but the loss, torque lost in the mechanical system. So TSH, TA minus TSH is the loss of torque. TSH, TA minus TSH is nothing but the torque loss. It is the loss of torque. Okay. Now, C point, we want to know the useful flux. Useful flux. So we know that back EMF EB is equal to phi Z N P upon 60A, where A is equal to 2 for wave winding. As the winding is given, the type of winding is given. So if you put this value, back EMF already we have calculated 233. Flux we want to know. Total number of conductor is 540. Speed is given 1000 RPM. Number of pole is 4 divided by 60 and divided by 2. This is the number of parallel path for the wave winding is equal to 2. So therefore the flux phi equals to 12.9 milliweber. So this one more parameter. Point D. Useful flux per pole, rotational losses. Rotational losses. Rotational losses So for calculating the rotational losses, we have to calculate the armature input. It may be the armature copper losses and all these things. So we can calculate armature input, armature input. We are just omitting the field calculation. So V into IA, which is equal to supply voltage is 240 multiplied by the current in the armature. So it is 1200 watt, 12,000 watt, sorry. Okay. Now copper losses. Copper losses, Cu loss, Cu losses, which is equal to Cu loss in armature plus Cu loss in brush. We are considering only armature circuit. So IA square RA plus brush drop into current, armature current, the current flowing into the brushes. So it is 50 square into 0.1 plus 2 into 50. So total losses, copper losses equals to 250 plus 100. So 350 watt. Now for armature input, we know armature copper losses. So therefore, rotational losses we can calculate. Rotational losses is equal to armature input minus Cu loss. Cu loss in the armature itself. Okay. So it is equals to 460 watt. If you put the values, you'll get this one. So this is the rotational losses which we are on to calculate. To understand these equations or the relation, we should remember the power stages in the DC motor. So next point is efficiency. So total input, total motor input equals to V into I, where I is equal to I equals to IA plus ISH as it is a motor. Look at to the figure. So 240 plus 51. So it is 50 plus 1, it is a 51. So the motor input is 12,340 watt. So we know the input, we know the output. So efficiency is equal to, this is the output as it is given, 11,190 watt divided by input 12,340 multiplied by 100. So efficiency of motor equals to 91.4%. So this is the last parameter. So in this way, we can do the numerical based on torque of the motor. So thank you for attending the lecture.